Okay, here's some variations on graphing the hyperbolas. If you like, you could pause and see if you could graph numbers 3 and 4 on your own. Otherwise, I can model. For example, number 3. It almost looks like a standard form. It almost looks like x squared over a squared minus y squared over b squared is equal to 1. However, there's a coefficient sticking out. And we can't just go on without it, with just the way it is. We have to make it into a standard form. So how do you get rid of that when already the constant is 1? Well, this is where in the beginning of the year when you studied Algebra 2, or later in the year when you studied Algebra 1, we talked about a quotient within a quotient. How do you rewrite this expression? Well, see if you could recognize this. This can be written as x squared over, since this says x squared times 16 over 25, we could take the reciprocal and say x squared over 25 over 16, and it will be the same thing. See if you could play with that and see if that makes sense. Now, if I rewrite the whole thing, they become a standard form. Why is that? Well, this is an a squared. What's the square root of 25 over 16? The a is 5 over 4. The b is square root of 81, which is 9. And c, the focus, we have to determine right now. And it's going to get a little weird because of that quotient 5 over 4. But it is square root of a squared plus b squared. And so a squared is 25 over 16 initially given over here. Plus b squared is 81. And how do you combine the two numbers over here? Well, back in 4th grade, the way we were taught was, is 16 times 81. Because the common denominator is 16. And that's going to be 1296. And 1296 plus 25 is going to be 1321. So that is square root of 1321 over 16. But I know what a square root of 16 is. So I could say square root of 1321 over 4. Now, is 1321 divisible by something? I'm sure, but I don't think I want to really spend the time. So anyway, this is going to be my foci. And this one is going to have a transverse axis horizontally. So it's going to have a hyperbola opening left and right. So we could start graphing. Alright, so what does this look like? This is going to be a little rough sketch, but see if I'm going to do this correctly here. Here we go. So it should say 5 over 4. Okay, here's 2. That is 1 and 1/4, so I'm going to say it around here somewhere. So the same is true on the other side of the y-axis. What's the b? Well, if that's a 2, 2, 4, 6, 8, 10, so 9 is over here somewhere. So the b is 0 and 9. Then same is true on this way, 2, 4, 6, 8, down there somewhere. And if I draw my imaginary rectangle, I could see my asymptote, my parabola or my hyperbola is going to look something like this. And same will be true on this side. My vertices coordinate is 5 over 4 and 0 and negative 5 over 4 and 0. Okay? I really don't care what a b is. That was just a point of reference so I could draw my asymptotal line. But what is my foci? The foci is 1321 square rooted over 4. Well, let's get a rough estimate what a square root of 1321 is. Square root of 1321. My calculator shows approximately 36.35 and divide that by 4. And that's going to be 9.08 approximately. So 9.08. So if that's 2, 4, 6, 8, 10, 9.08 is like somewhere over here. That's my foci coordinate. Plus or minus, or plus 9.08 and 0. Same as on this side. So, my critical points. My vertices are the coordinates plus or minus 5 over 4 and 0. My asymptote, since we have a horizontal transverse axis, we will have to use the function y is equal to plus or minus b over ax. And plug in the numbers for the variables, we get y is equal to b is 9 plus or minus 9 over a quotient 5 over 4x. So if I rewrite that, it becomes plus or minus, well, let's see, 9 divided by 5 over 4. So that becomes 9 times 4 over 5, right? Multiply the numerator, that's going to be 36 over 5x. And that's going to be my function form for the asymptote. Here's my vertices coordinate. And my focus is already been found over here. But there it is. Plus or minus square root of 1321 over 4 and 0. I hope you can see all this. Okay? Now see if you could try this number 4. Alright. Here I come. Now this time, the y is the leading term in this equation. But before you get excited, I keep tripping on this myself. You see that constant? Remember the standard form. At least standard form for the vertical transverse axis. It is supposed to be y squared over a squared minus x squared over b squared equals 1. You see that? So we cannot have a constant other than a 1. So that is not yet a standard form. So what we have to do is multiply two other terms by the reciprocal of that constant, which is 1 over 16. So when we do the distributive property, this 16 becomes 1. So that was easy. However, 16 times 16 is, well, I think that's 256. And 16 times 25, my calculator, sure, why not? 16 times 25 is equal to 400. All right. So y squared over 400. Perfect square. Isn't it? Yeah. All right, so there's my standard form. So what's my a? A is square root of 400, which is 20. What's my b? Square root of 256, which was 16. Yeah, and c, the foci, is the square root of a squared plus b squared. So let's evaluate. A squared is 400. 16 squared is 256. So if I square root those two numbers, we get 656. And let's see, 656. I know they're divisible by 16. 16 times 41. So 16 comes out as a 4, square root of 41. So that's my foci. And what is that approximately on the y-axis? That is this time, okay? So let's see, square root of 41 is approximately 6.4 times the coefficient of 4 equals 25.6 approximately. 25.6, okay? And that's going to be on the y-axis because the y term is coming first. So we're going to have a vertical transverse axis. So let's plot some numbers. Here we have, I hope everything fits in nice and neat. The A, okay? The A always follows the transverse axis. In this case, is vertical. So the A is going to be on the y-axis. So here's 10, here's 20. Boom! Here's 10, and here's negative 20. Boom! These are my vertices. 0 and negative 20, and 0 and positive 20. What's my B value? That will help me to determine the asymptote. Forgot the word. Okay, so here's 10, 20, so 16 must be somewhere over here. 10, 20, so 16 must be over here somewhere. And draw my little imaginary box around it so that I am able to get an idea what my asymptotal line is supposed to look like. And so when I draw my hyperbola, it should go along the side of the asymptote, touching the vertex, going back up, long, but never touching the asymptote. Okay? Same over here. This way and going down that way. To infinity and beyond. Down that way. So where's my focus? Well, it's at 25.6. So here's 20. 25.6, somewhere there. Okay? So the same is true on the opposite side of the origin, over here. Okay? And what's my formula for the asymptote? The function? Well, this time, for the horizontal transverse axis, it was y is equal to plus or minus. Last time we had a horizontal transverse axis, we had to use the formula y is equal to b over a x. Now that we have a vertical transverse axis, this time we have to use y is equal to plus or minus a over b x. And when we plug in the 20 over 15 or 20 over 16 as given, we end up with a reduced form of y is equal to plus or minus 5 over 4x. And so vertices are as 0 and plus or minus 20, as determined with the 20 over here. And the foci, we calculated it as plus or minus 4 square root of 41, which was just beyond that vertex. Opposite is true on this side. Okay, so there it is. Hyperbola.